Okay, so good morning. Now, before we start anything, before we start to exact content from strength of materials, let's have what are the prerequisites of this particular subject. The prerequisites means what are the concepts which you should know prior to this, so which will enable you to go to grab these newly added concepts very easily. So all of you must have gone through the subject called as engineering mechanics in your previous semester. So, just I would like to have an opinion from you. So you can respond to the poll question which I'm just raising. Uh, just raising it. Okay. So there are some few questions. I want all of you to answer them so that I will come to know. Okay, what is your understanding level before we start our uh, journey of your strength of materials. Is a polling screen visible to on your screen? So just reply to that. Whatever the things you know. We'll wait for one minute. Still 30 seconds to go. You can respond to those questions. Only 4 questions are there. I guess only one two people are addressed. Be quick and respond to that. So we'll come to know what is your understanding level. Okay, done. So we'll stop this polling and let's come to the result of this. Now, as a result, the very first question, as you can see, uh, very few, only 50% population have applied this. The answer to khali 60% लोगों ने 60 people have answered it. I would request others to be active on this screen. It's not a lecture where you can just sleep on the bed and listen to the strength of materials. So here in this particular today's lecture might be somewhat theoretical, but next time onwards we will be having so many calculations and derivations in this particular subject as your engineering mechanics. So the related to that, your first question was, have you all of you have passed the engineering mechanics subject in previous semester? How did you find the subject that engineering mechanics? There were so many options, and 57% people are saying it is easy to score good marks. So that is very positive for us, because as you know, the center of material will be on the similar lines to the engineering mechanics. Then 52%, that is another concern, 52% are saying it was too much calculation involved. So I'd like to address all those 52% people that the calculation is a part of mechanical engineering. So here onward, this excuse should not be there to have that the calculation is involved. We are born to do calculate as a mechanical engineer. So that is not the difficulty for us. It is the positive sign for us. We can do. The second, very few people have saying difficult to understand, so 8% people. But I would like to say these 8% people, they have to work little bit harder to know the concepts, to practice more. The engineering mechanics you might have found it difficult because of lack of practice. So if we have practiced on a larger for a greater period of time, then these calculations will never hurt you. The second question was your something related to your SI units. You must have gone through these units. So 1 MPa is equal to 1 Newton per meter square. I was asking a question based on that, and many people, 60% people have said this is not equal to, but unfortunately it is equal to. So we need to study that key, these units, MPa, GPa, KPa, and all those things, because we have been using only SI units. Now SI units will be there, but along with that, there are some common units which we'll be using in the course of this particular syllabus. So we'll be addressing to that. The third question was a quick means general knowledge of what you understand before knowing the concept from strength of materials. If a wire is stretched to double its length, what will be the strain in the wire? So this is based on your 12th standard syllabus, which you must have gone through, or if you are a diploma holder, then you must have studied this subject. So that is why I added this question, very basic question based on chapter 1. You can excuse me drinking a sip of water in between, otherwise it will hurt my throat. So if wire is stretched to double its length, the strain in the wire, only 13% people have answered it correctly. So rest people 13% छोड़ेंगे तो 87% people are in the wrong direction, so we need to get back on the track. So that is the understanding what we have learned. And fourth question was, which of the following are the items which do not affect the tensile strength? So here also 50% people have answered the correct way, but still the 50% people are in the some other dilemma, or it gave the wrong answer. So by having this particular poll, now I understand that we have a mixed group where people know some basic concepts from strength of materials, and some of them are completely raw in this particular subject. So we need to nurture them. So that is why I will ask you to be with me and be active on the screen. Okay. I guess I have answered everything, so no need to discuss that. Okay, so let us go back to our syllabus and let us have a quick revision of basic things which you might be knowing it because you have gone through mechanics, you have gone through physics in 12th standard, or if you are a diploma holder, you have gone through this particular subject basically. So today's lecture will be quite repetitive. That is necessary because to build a platform, those who are completely new and those who are already know, just to brush up the things which we have learned. Okay, so I am sharing my screen with you. Okay, is my screen visible to all of you?
Yes, sir.
Yes, sir.
Yeah, good.
Yes, sir.
Yes. One or two can answer, that is fine. Just to have the interaction, or if somebody is in good this one appearing, then they can even switch on the videos, because yes, two participants are raising hand. Yes, Dubey, you can speak on. Rahul.
Yes, Shah Rukh Khan.
Okay. Fine. If you have raised it by mistakenly, that is fine. Or else, if you have raising hand, then after that, after my call, you can unmute yourself and start speaking whatever you want to. So let's continue on. As you can end, strength of materials, that is our subject name. So let's go to the very first slide. That is, we'll be directly starting with the chapter 1, which is basically dealing with the simple stresses and strains. So what are simple stresses and what are strains? So we are going to discuss that, simple stresses and strains. Okay. So simple stresses and strains. The very first thing, as you can see, the loads or the forces. All of you must be knowing what are loads or what are forces, right? सबको पता होता है कि loads क्या है, forces क्या है. But still, let us understand what is a load. So basically a load is any external imbalanced force or action which is acting on a particular body, or it can be a particular object, or it can be a lever, mechanical lever ho sakta hai. There are so many mechanical objects or the tools where we apply some forces, and because of that there is some action. So that force can cause the displacement, that force can cause the moment, the rotational effect, and all those things. Okay, so in mechanics we have studied this particular part, what are the loads and what are forces. So all of you are quite uh, knowing this key, what are loads and what are forces. So the loads are nothing but an external wait a minute, I will put this waiting room off, because every time I need to go to the waiting room and I want to admit them, or else I will make one of this co-host. He can just see on who is ready to is Om is there. Om from Mechanical B.
Yes, sir. Yes, I am there.
So I'll make you the co-host. Those who are coming late, you can admit them.
Okay, sir.
Just I'm searching you. Om. Oh, yeah. Okay. Now you can admit irrespective of me. So I don't want to stop. I don't want to stop in between. Okay, fine. Thank
Yes,
you.
sir.
So what is a load and what is a force? So as you can see, a load is nothing but an external uh, unbalanced, or we can say imbalanced. Okay, unbalanced action. Okay, which can cause what? Which can cause a displacement, right? Can cause rotation, etc. So there will be some effect of applying this particular force. So that is the load or force. Now all of you are very much aware of what are the loads. So if I classify the loads, okay, so you must have studied the very first type of load as point load. Have you heard of point load? So you must have heard of the second type of load, that is UDL. सबने सुना है UDL. And the third type of load, it can be, let's say, UVL, right? These are very common terms which you must have used in mechanics, basically in statics. Okay, so a point load is nothing but what? It is a load acting at a particular point. For example, if I have a simply supported beam and like this, okay, so if I can have this kind of point load, let's say this point load is 10 kilonewton, and these are the reactions, let's say we can call it as RARB, right? So this all okay, point load, it acts at a particular point. Or basically, now what is UDL? So UDL stands for
Uniform distribution of load.
yes, uniformly distributed, right? So
Yes.
uniformly distributed, and UVL stands for uniformly
Varying.
What vertical
varying load.
varying? Sorry, sir.
Okay, uniformly varying load. Now uniformly distributed and uniformly varying load may there is a difference. So what is uniformly distributed load? So there is uniformly distributed loads means the load intensity remains constant throughout the
Constant.
span, right? So it can be represented by this UDL sign, where the intensity can be given as, let's say this intensity is 5 kilonewton per meter of length. The intensity can be, it is not necessary that the intensity can be only per meter, it can be per meter square also. If I have a linear object, then उसपे per meter पे variation होगा. If I have a let's say I have a table top, मतलब टेबल है मेरे पास, and वो टेबल पे कुछ लोड एक्ट हो रहा है, so in that case the load will be on entire surface area, so it will be load per unit area. So that is also uniformly distributed. So it's not necessary that the intensity of uniformly distributed load will be only in kilonewton or newton per meter, it can be per meter square as well. Okay, and there can be support like this. ठीक है, it can also be displayed like a rectangular shape में भी हम लोग उसको denote कर सकते हैं, right? In this way you must have seen it earlier as well. So ये same type है, we can denote this as 5 kilonewton per meter. Here we assume that the rectangular is having a height of 5 kilonewton, right? Now uniformly varying, as you can see, varying load मतलब variation में भी कुछ pattern हमें पता है क्या? So that is known as uniformly varying load. So uniformly varying load में the most common load you must have come across, the most common load you must have come across is the triangular load, right? Triangular, or the another type is trapezoidal, right?
Yes,
Triangular
sir.
load तुमने देखा रहेगा. Triangular में क्या है, zero at intensity of the load is 0 at one end, and at other end it can be 10, 5, whatever is given to us, and then we find out the this one, right? Or other thing, it can be trapezoidal load. How we solve this trapezoidal load? So this trapezoidal load we divide into a UDL and a triangle. So this becomes UDL and this becomes UVL, right? A triangular load and a rectangular load, and then we solve this. So this was also we have well addressed in engineering mechanics. Okay. Now apart from this, uniformly varying load ka meaning kya hai? The uniformly varying load is not only limited to this a triangular and a trapezoidal load. It can be, the load can be a curve as well. It can be a curve. But what we mean by uniformly varying is, if you know the equation of this particular curve, if you know the equation of curve, then you can call it as uniformly varying load. Then you can call it as uniformly varying load. Okay, if you know the equation. अगर equation पता है तो ही, because if you know the equation, you can integrate it and you can calculate the equivalent of it. But if you don't know, if you wrote, if the variation is random, and if you cannot figure out how the variation goes, I can say that the variation is parabolic, I can say it is cubical equation, I can say it is cycloidal, so and then. So I have so many equations you must have studied for curves in mathematics. If it is a parabola, standard parabola, y square equal to 4x, x square equal to 4ay, all those things, right? So if it is known to us, then it can be a uniformly varying load. But if you don't know the equation, then it is purely non-uniformly varying load. Okay, so right now we are not going to non-uniform varying load. We will be restricting ourselves to uniformly varying loads only. Okay, very good. So you know this concepts from mechanics. Now let us understand the nature of loads, or nature of force rather, we can say. What are the nature of loads or nature of forces? So now the force can be what? The force can be, as you can say, it can be of, you can see this is pulling force and this is a pushing force, right? A force can be either of pull kind of force or a push kind of force. Okay, what do you mean by pull or push? Basic concepts है कि force में हम लोग एक तो ढकेलना चाहते हैं या फिर pull करना चाहते हैं. तो अगर ढकेलेंगे तो it can be called as push, and अगर खींचेंगे तो it can be pulled. So based on that, the nature of load in this particular engineering mechanics as well as in strength of materials, we'll be calling the load as either tensile load, or we can call it as the compressive load. As you can see, tensile means the load is going to extend this particular members. That is why we can call it as tensile. Okay, and the others are trying to compress it. That is why we are calling it as compressive. Apart from this, the loads can be of different shape. We'll be coming that to that particular point in the later course of time. But these are the basic things which we have. You must have studied in statics. In statics of the engineering mechanics, the earlier 4 to 5 chapters. Okay, and so with this we have understood the very basic things of the. Let's go to the next slide to understand the next part, which is now the very important part. Few of you can answer here. What is stress? Does anybody know? Can ready to answer? One people can easily unmute and tell me if you know what is stress. Nowadays the stress has become a very common thing in this one also. Yes, somebody is chatting while on the screen. I cannot see your chat, but still you can unmute and madam, this particular lecture is open to those who are saying constructive things. You can just unmute and tell me what is stress.
Force upon area.
Internal resistance to external force.
Very good. Two of them has answered very well. One is saying the mathematical formula to calculate, other is just describing what is internal resistance. Okay, very good. Okay, so stress is, can stress be equal to pressure? Can I say it is equal to pressure? Yes. Can I say it is equal to pressure?
No, sir. Cross
Some
section
people are
area
saying
thrust.
yes, some people are saying no. Okay.
Yes.
Okay, fine.
Pressure into strain.
Yes,
Fine. Yes, yes. So stress at some points it can be equal to pressure, but at not every time, right? So therefore, we have different physical quantities enlisted in your physics. That pressure is a different thing and the stress is a different thing. So let us first understand what is stress, and then we'll come back to what was pressure. Okay. So let's understand what is stress. So as somebody rightly mentioned, the stress is nothing but the internal restoring force. Okay, so whenever we apply force on any material bodies, these forces they trying to change the shape, size, or the, for example, if I take a rubber band, सबके पास घर पे normal rubber band होता है, right? You take this rubber band and you pull it. What will happen? The length will increase, right? But as soon as you are pulling it and you are holding it, whatever the energy you whatever the energy you have given as an input to pull this particular rubber, okay, will be now responsible for restoring it once you release it. तुम release करोगे तो it will again regain the shape and size. Okay, so we have we have been already knowing the what are elastic materials and what are plastic materials. The elastic materials are those who can deform while applying the deforming force, and they can regain the shape and size. But plastic materials, they cannot regain. I am very clear that plastic material does not mean they are made up of plastic. The materials which cannot regain are known as plastic. So plastic is a category, not the material. So the materials basically can be classified as rigid material, a rigid one which cannot deform, which are hypothetical concept. Rigid materials do not exist in nature, right? The other one is elastic materials which do deform on applying the deforming forces, and they can regain the shape and size. The third one is the plastic material. You apply any small amount of deforming force, they will deform and they will never regain. The best example is the clay, wax, and other plastic materials as well. Okay, so there are some materials which cannot regain. But the elastic materials, if you are focusing on those elastic materials, when they deform, there will be some internal resistance for deforming, and that internal resistance creates the stress or the pressure inside the material molecule. Because let's say, suppose for example, I have a let's say I have a rod. I have a simple rod like this. Okay, and now I'm trying to pulling it out. Let's say I'm trying to pull it out by applying a deforming force, let's say P. So there were so many molecules inside. यहाँ पे बहुत सारे molecules थे. So what will happen when I'm trying to pull this, and if the length of this particular rod increases, what will happen? The molecules are going to go away from each other. The intermolecular distance between them is going to increase. Now these intermolecular, we know that in solids or in any of the materials, the intermolecular, the forces are there. In between two molecules, there will be some intermolecular forces. So when you're trying to pulling out, you are doing work against that intermolecular forces, and that intermolecular forces those intermolecular interaction will reserve or will store that particular energy which you have applied while elongating them or while compressing them. And once you release that particular force, it will regain the shape and size. So therefore, the internal restoring force which enables the materials to regain their shape and size, they cause the stress. So basically, we define stress as the internal restoring force per unit area. Okay, now what do you mean by per unit area? Because we apply, now you can see the force was applied only on this particular cross section area, right? It was not applied on the entire surface. That is why the stress and pressure are different. Basically, when we talk about pressure, the pressure is acting on entire surface, entire body surface. Then only if the force is acting on entire body surface, we call it as force per area is pressure. And if the force is acting on a particular cross section or particular part or a particular face of the body, then the force upon that area will generate stress rather than inducing pressure in that. So therefore, this pressure and stress are quite different. So stress is internal restoring force per unit area, and pressure is simply force upon area, where basically the area is entire surface. Okay. Now internal restoring force per unit area we have seen. Now what will be the SI unit? So the SI unit of this particular this will be what? As you know, it is force per unit area, or we can call it a restoring force upon area. So the SI unit, the force ka unit is Newton, and the area is meter square. So the SI unit is Newton per meter square, or in SI system we also call it as Pascal. So we can use Newton per meter square or Pascal. But as you know, in mechanics as well, these dimensions, all the dimensions we are using in metric system. In engineering mechanics or in mechanical engineering, the dimensions we measure is majorly in that is in metric system, the millimeters, and all the basic unit which we use in millimeter. So instead of writing in 1 Newton per meter square, we'll be using, now let's say if I write 1 Newton per meter square के बदले अगर मुझे 1 Newton per millimeter square करना है, so what I need to write down? So I need to convert, right? So मुझे क्या करना पड़ेगा? Convert करना पड़ेगा. So how will I convert that? So 1 Newton per millimeter square, I want to meter square, I want to convert into millimeter square. So 1 Newton is as it is meter. 1 meter is how many millimeters? I know that 1 meter is 10 raised to 3 millimeters, but उसका square है यहाँ पे. So I need to square this up. So it will be 1 Newton per 10 raised to 6 millimeter square, right? ये 10 raised to 6 कहाँ पे जाएगा? ऊपर जाएगा. So I can call this as ठीक है, 10 raised to minus 6 Newton per millimeter square. Okay, Newton per millimeter square. So 1 Newton per meter square is 10 raised to minus 6 Newton per millimeter square. Now we are trying to, now you can see this, you can see ये 1 Newton per meter square है यहाँ पे, right? Can I write this as 1 Newton per meter square is nothing but 1 Pascal? So I can write this as Pascal. Okay, so here also 1 Pascal is equal to 10 raised to minus 6. ये minus 6, if I shift it to this side, it will be 10 raised to 6 Pascal is equal to 1 Newton per millimeter square, right? This is absolutely correct. So what is 10 raised to 6? 10 raised to 6, the suffix which we use is mega. So therefore I can write this as 1 MPa, 1 megapascal is 1 Newton per millimeter square. This was a question from the poll, which you should remember. So this is the most common unit which we'll be using in entire strength of materials. 1 megapascal is nothing but 1 Newton per millimeter square. So when you are working in Newton and millimeter, the stress unit you're going to get is 1 MPa, not Pascal or not Newton per meter square. Understanding it? So this is very, very important to understand. So you should keep it in mind. Okay, now let us quickly figure out what are the other prefixes we can use. What are the other prefixes I can use? So other prefixes which are very mostly used are kilo. You must be knowing it. K stands for kilo. What is the prefix which we use? Kilo is 10 raised to basically 3. Then we use mega is sorry. We use mega. Mega is capital M, or million we also call it as. So it is 10 raised to 6. Okay, and we use giga, that is capital G, it is 10 raised to 9. These are all common things which you have been using. But the mostly we will be using is, suppose if the thing is given in 1 GPa, most of the time they will give the values in GPa and you have to convert it to the system which we are following. So some लोग system follow कर रहे हैं Newton and millimeter का, because metric system में the force is in Newton and the distances or the dimensions of the objects are in millimeter. So therefore 1 Newton per millimeter में अगर मुझे वो काम करना है, that means I need to work in MPa. So whenever you will come across GPa, you can simply write down 10 raised to 3 MPa. 1 GPa is 10 raised to 3 MPa, because G and M में difference कितना है? देखो, G stands for 10 raised to 9 and M stands for 10 raised to 6. So the difference is of 1000, that is 10 raised to 3. So therefore 1 GPa is 10 raised to 3 MPa. Now this is very, very important. Why I'm telling you the first lecture? Because there will be a few people. There will be, just a minute, I forgot to plug in my laptop video. Just give me a 1 minute. Yeah, done. So now, don't. Yeah. So we discussed what is GPA, what is MPA, and this things you have to keep in mind, because this we'll be regularly using in our calculations, and in numerical solving. This one will be very frequently used. So 1 MPA is 1 Newton per millimeter square, and 1 GPA is 10⁻³ MPA. These are the things which you require. Now let us understand the types of stresses, which will come across. So what are the types of stresses you know? So very basically, the stresses can be divided into only two types. It can be divided into only two types. One is, as you can see in the bottom, the normal stress, and the other one is the shear stress. So the stresses are divided into basic broad way. It can be divided into two types. One is normal stress, and other one is shear stress. Okay. So in entire strength of materials, we'll be dealing with these two types of forces, these two types of stresses, normal stress and the shear stress. Now, what do you mean by normal? Normal means perpendicular. The normal meaning here is perpendicular. So what do you mean by normal stress? So that is the next point which we'll be understanding. Normal stress and shear stress. So what is normal stress? So normal stress is when the force is acting perpendicular to the cross section of the body. Okay, when the force is acting perpendicular to the cross section of the body, the stress induced, we call it as normal stress. Okay, so we can, I am writing it here, when the deforming force is acting perpendicular to the cross section, to the cross section of object or the material. Okay, so this will be calling as normal stress. तो यहाँ पे you can see there are normal stress के लिए मेरा same diagram बना है. Now normal stress can further be classified. भाई force perpendicular हो सकता है, but उसमें normal stress can further be classified. Right now we will be studying only two classifications of this. That is, normal stress is now classified as the tensile stress, or it can be the compressive one. It can be tensile, it can be compressive. Now what do you mean by tensile? So tensile का meaning क्या होगा? So tensile means they are trying to elongate. Okay, so it will try to elongate the material, and the compressive means it will try to compress the material. That means the material is going to shrink in compressive case, and it is going to elongate in the tensile case. Okay, so as you can see, this is the example for tensile stress, and this is the example for compressive stress. Okay, this is for compressive. Getting it as? So now how this, for example, if this force is P and if the area of cross section is A, then the tensile stress I can denote. Now always in strength of material, the stresses, we are going to denote them by a letter known as sigma. So sigma is the stress which we will be writing as P upon area. Here we are not writing F as the force, we will be using P as the force. That is our convention. You can use F also, but still in some of the textbooks you may find sigma as the stress, or they may write F as the stress. In some of the textbooks they have given letter F, they have used for stress, but we will be using sticking to sigma. So sigma is stress and it is P upon area. So the normal stress will be calling it as sigma N, will be calling it as sigma normal. Okay, so the normal stress, and if it is tensile stress, then we'll call it as sigma tensile, and if it is compressive stress, we'll call it as sigma compressive. Okay, so the sigma tensile can be load upon the cross section area, and sigma compressive here also it is the load upon cross section area. Here the calculation doesn't make any difference, but the effect of that particular stress is the different. In the first case, the elongation will happen. Here there will be elongation, and here there will be compression. Okay. So this is all about what are the basic stresses. Normal stresses can be further divided into tensile and compressive. Now, where we get to see these normal stresses in real life? Can anybody suggest where you have seen this normal stresses to be is acting? Normal stress is acting. The best example I've given you rubber, but rubber is not a practical example. Time pass के लिए हम लोग rubber stretch कर सकते हैं, but not the real life example where you will get to see this tensile stress is acting on the actual material, the components. Anyone can answer here?
सर वो क्रेन होता है ना वेट
Yes,
लिफ्ट
very
करने के
good
लिए.
example, rightly cited. Who is this?
शिवम मैके 50.
Okay, but okay, one more suggestion. When you are responding, तुम अगर वीडियो ऑन करोगे तो भी चलेगा, because I would like to see who are the active members in this class.
सर वेबकैम नहीं है, सॉरी.
ठीक है, or else you can tell out the name also, because right now on this share screen I am not able to see who is speaking. Okay, fine, fine.
Okay,
But that is an optional case. That is not mandatory. You may answer anyway.
सर वो आयरन का स्प्रिंग होता है ना सर, जो कुछ भी चीज हैंग करने के लिए.
Yes. कौन सा? I didn't get you.
स्प्रिंग सर, स्प्रिंग
Yeah,
होता है ना
okay,
सर.
springs can be. The example is wherever we use this pulley or fulcrum mechanisms, pulleys होते हैं या फिर cranes है, overhead cranes है या फिर normal earth movers है, उसमें सब जगह पे जहाँ पे हम लोग cables use करते हैं, all these cables are subjected to tensile stress, or they are subjected to tensile stress, and वो elongation होगा उसमें, and where we get to see the compression, all the members which are subjected to compressive loading. The best example is the basic structures. जो भी structures होते हैं, for example I am right now in Mumbai metro bridges चल रहे हैं, तो सबसे पहले वो जो pillars बना है, pillars के ऊपर ही सब कुछ load आने वाला है, right? So the pillars are going to subject to compressive load. So they are designed such that कि वो maximum compressive load ले सकते हैं even when the train is running and even when the passengers are going to board on it. Okay, so the action calculations are done and उतना compressive load वो pillars को लेना है, and not only for a particular period of for a long duration, maybe for next 100 years it should take that take care of that particular material. We'll come back to that point in a little bit after in this particular lecture. Just figuring out what is the time frame. Okay, fine. So now let's go for the next important point, which is the shear stress. Okay, now what is shear stress? Okay, what is the shear stress? So what do you mean by shear is nothing but shear stress, also called as tangential stress. It is also known as tangential stress. Okay, it is also known as tangential stress. So as the name indicates, tangential means here the load is not going to be perpendicular, it is going to be parallel to the surface. So for example, the best common example you must have studied in earlier physics standards also, like if you have a cube, okay, if we have a cube like this, if we have a cube like this, okay, it is fixed at one end. ये जो उसका bottom end है, we are fixing it up. Okay, ये cube ऐसा है, dimension में बनाएंगे तो this is a simple cube. Now this is fixed at one end, and if you are trying to apply the load on this upper surface, now you can see the load which is applied is tangential, right? Now the load is not perpendicular, it is tangential on this particular area. ये load ये particular area पे tangential है. So because of this, what is going to happen? Because of this, the load which you have applied, this particular shape may deform. And वो deform कैसे होता है? So the deformation will be in this particular manner. The deformation will be like this. The upper face will laterally displace and the lower face will be remaining fixed like this. It will displace like this. Okay. So now there is a change in the shape of the body. Okay. If I draw this on two-dimensional plane, what will happen? This way. So for example, if I'm just looking at the front plane or the front view of this particular object, it is fixed at this end and I have applied the load on this particular surface. Let's say the load is P and it is applied, then it will deform like this. Okay, it is going to deform like this. So here load was a tangential to it, and because of that the shape is changed. There will be some angle which is induced. Okay, so shape change hoga yahan pe, and this is the displacement. We also call this displacement as the lateral displacement, right? Lateral displacement. Okay, so this is we are calling as shear stress. Okay, because it causes change in the shape of the body. Okay, now what are the real life examples where we get to this kind of shear stress? The best example is the shearing of the material. Is, let's say I have, for example, मेरे पास ऐसा कुछ metal plate है. I have this particular metal plate. Okay, now it is to be joined on the another plate. एक दूसरे plate पे उसे plate के ऊपर उसको मुझे join करना है. You can see this is another plate at the bottom, and ये यहाँ पे मैंने इसको screw nut bolt लगा दिया. ये nut bolt इसके अंदर जो अंदर रहेगा ऐसे, तो मैं उसका ये बना रहा हूँ dimensions, right? Nut bolt उसके अंदर ऐसे रहेंगे, right? Now if you are pulling this plate on this side and if you are pulling this plate on the other side, what will happen? ये जो nut bolt यहाँ पे तुमने attach किए रहेंगे, ये दोनों screws, उसके ऊपर यहाँ पे क्या होगा? Shearing action होगा. मतलब for example, if I draw that particular bolt, तो उसका ये क्रॉस सेक्शन और उसका ये जो नीचे का क्रॉस सेक्शन है, यहाँ पे एक पे लोड ऐसा है और एक पे लोड ऐसा है. It is going to shear off. ठीक है, the load is tangential to this particular cross section of the bolt. ठीक है, so this is the major case जहाँ पे shearing load act होता है. But the other case is the scissor. कैंची सबने यूज किया रहेगा normal. So whenever I use this particular कैंची वाला thing, या फिर scissor मैं use करता हूँ, तो for example, let's say I have this particular things to be let's say a piece of paper and I want to cut it off. तो अगर मुझे उसको cut करना है and I am using the scissor, so I am using this scissor, यहाँ पे मैं force apply कर रहा हूँ on this parallel to this cross section. So this is going to cut. The scissor applies you gives you the shear stress or shear force on the cross section of the paper. पेपर का क्रॉस सेक्शन बहुत थीन होता है, इसलिए अगर थीन पेपर होगा तो इजीली कट होगा, फोर्स कम लगेगा. थिक पेपर होगा तो यू विल रिक्वायर मोर अमाउंट ऑफ फोर्स टू कट इट. Getting it? So that is the shear force which we apply and which enables it to cut. Okay, so that is also you should keep in mind कि scissor is subjected to shear stress. Okay, understanding it. What is shear stress and where we get to see this real life examples of shear stress. Again, the shear stress can be denoted by the letter sigma t, but the most commonly we'll be using it as sigma. Instead of using sigma, we'll be using it as tau. We'll be calling it as tau as the shear stress. Okay, this is a simple different letter which we'll be using it for shear stress, because sigma tangential can be another in further course of time we'll be using sigma normal, sigma time very frequently. So there, to differentiate it from shear stress, we'll be using from here onwards we'll be using shear stress as tau. Okay, so the symbol which we'll be using for shear stress is tau. Yes, Tushar, can you raise your hand?
Yes, sir. Actually, I had a doubt regarding the scissor example that you gave just right now.
Yes.
When a paper is cut, the scissor we hold is in the perpendicular direction to the paper, so the surface of the paper.
Yes.
So how it will be shear stress, not?
Yes, yes. Okay, I will address this. One more has raised a question in chat box. ये make be 28 कौन है? Private messages मत भेजो रे. You can send your feedback afterwards. No need to. Okay, fine. Okay, Tushar, I'm coming back to your point. So now, as you can see, let's say, suppose if this is my paper, okay, and I'm using, now this is the plane of the paper, ये plane है paper का, right? I'm using scissor like this. So my scissor is perpendicular to the plane of the paper, but you see the cutting edge. ये cutting edge है scissor का, ये cutting edge, ये cross section को कैसा है? Tangential. I'm talking about this cross section, not this one. ये तो इसका face है. This is the face of the paper. This is the cross section of the paper, right? दिख रहा है ये?
Yes, sir. Yes, sir.
तो I am applying the force tangential to this cross section. मैं face पे ऊपर force लगा के cut नहीं कर सकता ना paper को cut करना है tangential cross section wise में, right? So therefore I'm applying scissor से parallel force to the cross section. That is why it is shear stress, not the normal. Okay.
Yes.
I hope I answered your query. Now let's go to the next question, which is strain. Now all of quite along हम लोग अभी stresses के बारे में discuss कर रहे हैं. तो whenever we apply stress, there will be some deformation in the object, in the material, and that is going to cause some changes in the dimension of the body, and those changes can give us the value of strain. So all of you, the strain is nothing but the very simple definition. I can make it That is, the strain is the change in dimension per unit original dimension. The change in dimension, okay, upon the original dimension. Original dimension. So whatever the force you apply, because of that, whatever is the change in dimension, that if you compare with the original value of that dimension, that gives you the strain. As you can see, the dimension upon dimension, that means if it is a length upon length, area upon area, volume upon volume, it is not going to have any unit. So therefore, it is a dimensionless quantity. Dimensionless quantity. So what is the unit of strain? It is no unit. The unit of strain is, there is no unit of strain. Okay, so therefore change in the strain. Now what are the types of strains? As we had the strain types, we'll have the stresses, types of stresses, we'll have the types of strains. Okay, so let us now understand what are the types of strains. The types of strains can again classified as the normal stress and the shear strain, the normal strain and the shear strain. Okay, now the normal strain, the strain is denoted by the letter E or the letter epsilon. You can be denoted by epsilon or E. Okay, in many of the books we have been using E or epsilon. Both the notations are quite common. So we will be in our lectures we will be using E. Okay, so small e stands for strain and sigma stands for stress. So my normal strain will be E normal and my shear strain will be it can be theta or it can be simply E tangential or the shear strain. The shear strain is basically a different concept which we'll be discussing here in above example only. So the types of strain, so normal strain can further be classified into tangential strain and the compressive strain, or tangentially tensile strain and the compressive strain. So the tensile strain is nothing but E tensile and compressive is nothing but E compressive. So you can see compressive में क्या होगा? तो compressive में there will be a decrease in the dimension. For example, अगर मैंने यहाँ पे load P apply किया है, ठीक है? तो अगर ये tensile है, तो it is going to increase in size. यहाँ पे इसका size क्या हो जाएगा? बढ़ जाएगा, right? So let's say I am calling the earlier length as L. If the earlier length of this particular specimen was L and the new length is, let's say, L plus delta L. The new length is L plus delta L. Then what is my change in the strain? The change is nothing but delta L and the original length was L and it is positive change, so I'll be calling it as plus. But if in case of this particular case, यहाँ पे क्या होगा? It is going to decrease. So for example, यहाँ पे अगर मैं देखता हूँ, so if this length was L, after the application of this, it is going to decrease in the length. यहाँ पे इसका length कम हो जाएगा. So अगर length कम होता है, okay, तो अगर यहाँ पे length कम होता है, तो in that case, what I can write down is, I can simply write down minus delta L upon L, which will be decreased. So strain can be positive, negative based on the either increase or decrease. Okay, now the shear strain. Now shear strain is basically, you can see where when we discuss the shear stress, the strain is nothing but shear strain causes a change in the shape. So यहाँ पे देखो, यहाँ पे shape change हो रहा है, मतलब there is a lateral displacement and upon some perpendicular distance. You can see this is the upper face which is going to move and this is the lower face which is fixed. So the perpendicular distance between this upper face and the lower face is, let's say, L, and the lateral displacement is, let's say, X. I'm calling it as. Then the shear strain, it is also denoted by theta, or it is approximately, basically it is equal to tan of theta, which is given by the lateral displacement upon the perpendicular distance. Okay, it can be, if it is a cube, it is side of the cube, or if it is a parallelepiped, rectangular parallelepiped, then it will be the thickness of that particular parallelepiped. Okay, or it can be the distance between the upper face and the lower face. Okay, so tan theta. Okay, that is the displacement. So theta can either be, if it is only theta, then it can be measured in radian, but radian also it is dimensionless, so the shear strain is going to be dimensionless. Okay, have you understood this? What are the types of strains? Strains are basically on the types of stresses only. The stresses types, whatever we have discussed, based on that the strains can also be discussed. Okay, so Here we understood what are the basic types of stresses and what are the basic types of strains. Now let us go further to